The Northrop Grumman X-47B was a successful step in the U.S. Navy's quest to build the first carrier-capable unmanned aerial vehicle. After the promising Pegasus project of the early 2000s, the service teamed up with its industry partners and developed a truly outstanding piece of engineering, a strike fighter-sized drone. Throughout the 2010s, the X-47 underwent several modifications and a subsequent series of special tests that not only proved the concept was feasible, but demonstrated the machine's reliability. The expectations were sky high, and it was now time to prove if such advanced technology could be readily exploited, or if the mighty UAV was too progressive for its time. Proof of concept. Until the 2000s, the U.S. Navy was not fully committed to developing a practical unmanned combat air vehicle, let alone one that was carrier-based. But then, the Sea Service partnered with the Air Force, Boeing, and Northrop Grumman in a concept exploration program led by DARPA to come up with a single solution for both services. The specifications called for an aircraft capable of deck launch and recovery, integration with command and control systems, and viable operation amidst a carrier's electromagnetic interface. Needless to say, the airframe had to withstand the corrosive effects of salt water. The Navy's interests included deploying the UCAV for reconnaissance missions as a means to penetrate into protected enemy airspace and identify targets for upcoming raids. Hence, in early 2001, the service awarded a contract to Northrop Grumman to develop an unmanned combat air system demonstrator that would be known as the X-47 Pegasus. The resulting demonstrator turned out to be a simple black arrowhead without a vertical tailplane. It had a leading-edge sweep of 55 degrees and a trailing edge of 35 degrees, and 6 control surfaces with 2 elevons and small flap structures. Plus, it was powered by a single Pratt & Whitney Canada JT-15D5C small high-bypass turbofan engine. While the flight test program did not involve weapons delivery, the aircraft was equipped with 2 weapons bays, able to carry a 500-pound dummy bomb to simulate operational loads. Besides, the Pegasus would evaluate technologies for carrier deck landings. Nevertheless, the joint endeavor was terminated in 2006, and each service proceeded with its own projects. Consequently, the Navy selected Northrop Grumman's proposal for further development. Consistency. Following the proof-of-concept demonstration, a full-size technology demonstrating UCAV was born. It had the exact same size and weight as the projected operational aircraft to carry out more realistic tests, and the X-47B would also have a complete weapons bay to carry existing missiles. The Sea Service went through with the undertaking as part of the X-47 initiative, which took almost an entire decade. In late 2008, the Air Vehicle 1 prototype was completed and rolled out in Palmdale, California. But further work was needed due to its software's complexity. A year later, the aircraft underwent active towed taxiing tests, but didn't actually try taxiing under its own power until early in 2010. Formal flights started later than initially planned, with the first flight taking place in early 2011 at Edwards Air Force Base. However, the first flight performed in cruise configuration, with its landing gear retracted, wouldn't happen until the fall. Meanwhile, AV-2, the second demonstrator, first flew towards the end of that same year. Although the 2 demonstrators were initially planned to go through a 3-year test program, their performance was so consistent that preliminary tests ended after barely 16 flights. Soon after, the Navy continued with sea trials, namely carrier launches and recoveries, and also autonomous in-flight refueling. The models were eventually refitted with aerial refueling equipment and software for the next stages. Notably, they were never armed. Then, as the test crew continued refining the remote control techniques required for proper routine functions, akin to a piloted aircraft, the engineers' most significant challenge became overcoming the maritime environment's corrosive effects on the vehicle's exposed surfaces. Firsts. In early 2012, the company tested a wearable remote control system that allowed ground crews to manually steer the drone along the deck. Then, halfway through the year, the model began high-intensity electromagnetic interference testing. Aircraft carriers represent perhaps the most complex electromagnetic spaces on any surface ship whenever their multiple radars and systems are switched on. The X-47B initialed its carrier-based evaluation aboard USS Harry S. Truman in November, and in less than a month, the prototype successfully completed the first at-sea test phase. Fortunately, the aircraft proved to be compatible with the carrier's flight deck, hangar bays, and communications systems. By the summer of 2013, the X-47B performed an arrested landing on a simulated carrier deck at Patuxent River, Maryland, and a few days later, it launched from USS George H.W. Bush, marking a milestone in drone development, as it was the first time a UAV was catapulted off an aircraft carrier. After launching, the UAV was transferred over to a second pilot, who flew it successfully from the Chesapeake Bay to Naval Air Station Patuxent River. Later, it also proved capable of achieving touch-and-go landings and takeoff from the deck while underway. The X-47B also accomplished the first arrested landing of a UAV on a carrier at sea, further propelling the program forward in its mission to create the first carrier-operational drone. However, the model had a technical issue during the third try and was diverted to the Wallops Flight Facility in Virginia. As one of its 3 navigational subsystems failed, the remaining 2 identified the problem and alerted the operator, who followed the protocols to abort the landing attempt. The mishap ended up proving the drone's reliability and autonomy. A true flying wing. Like many other popular drones across the globe, the device's design featured a defined triangular shape. Moreover, the aircraft was a true flying wing, given that it didn't appear to have any obvious vertical surfaces, similar to the Northrop Grumman B-2 Spirit stealth bomber. As for its power plant, a single Pratt & Whitney F100 220U turbofan engine was buried within the fuselage, and it aspirated through a shallow duct along the forward spine, while the exhaust went through a specially designed port at the rear. Evidently, the lack of a pilot housed in a typical canopy left room for significant internal volume, which could be taken advantage of when carrying specialized mission equipment, armament, and fuel stores, or additional avionics and subsystems. Production units would be fielded with 2 internal weapons bays, just like the Lockheed F-22 and F-35 fighters, and its capacity amounted to 4,500 pounds of ordnance, with guided munitions being its most likely load. Furthermore, its carrier-based capabilities demanded key qualities integrated into its design, namely the folding of its wings for easy storage, a reinforced undercarriage with an arrestor hook, and corrosion resistance to counter the effects of its hostile environment. The X-47B's undercarriage was retractable and consisted of 2 single-wheeled main legs and a twin-wheeled nose leg. Capabilities. The drone's flight system is autonomous, and its navigation is handled by a hybrid vision-based global positioning system. Meanwhile, its flight path is pre-programmed, while it operates under the supervision of a mission operator. The device has a 62-foot wingspan, or less than half when contracted, a length of 38 feet, and a height of 10.4 feet, and it can reach a cruising speed of 685 miles per hour, or a high subsonic speed of approximately Mach 0.45. Plus its operational range exceeds 2,100 nautical miles. Likewise, the X-47B managed to reach a ceiling of roughly 40,000 feet. The drone was also fitted with electro-optics, infrared, synthetic aperture radar, inverse SAR, ground moving target indicator, electronic support measures, and maritime moving target indicator sensors, while its airframe and internal systems eventually incorporated stealth characteristics or low observable relevant requirements. Too close to the sun. The UCASD program demonstrated the feasibility of operating drones on an aircraft carrier at the cost of $813 million. By the spring of 2015, the fighter-sized drone successfully completed the first-ever autonomous aerial refueling demonstration, and shortly after, the primary test program was finished. Still, roughly a year later, the Navy decided to convert the previously surveillance and strike-capable aircraft into a reconnaissance aerial refueling UAV with limited strike capability. The subsequent unmanned carrier-launched airborne surveillance and strike project was cut off in favor of the MQ-25 Stingray carrier-based aerial refueling system, or CBARS. For all its success, the X-47B eventually raised concerns about its costs and proved insufficiently stealthy for the project's needs. There was an initiative to convert the demonstrators into museum exhibits, but the prototypes remained in active flying condition instead, allowing for subsequent evaluations and variants. In late 2017, the X-47B proved useful as a testbed for the MQ-25 proposal, but Northrop Grumman soon retired from the competition. Both UAVs remain stored in a hangar and are only used for upkeep static engine runs out of the public view. Still, the technology and expertise gained from the remarkably successful venture earned much recognition and awards, like the 57th Annual Laureate Award for Extraordinary Achievements in Aeronautics and Propulsion, hosted by Aviation Week, and the 2013 Collier Trophy for Excellence in Aeronautic Technology by the National Aeronautic Association. Furthermore, the X-47B's legacy was passed down to the X-47C, which may restore its predecessor's honor, should it meet the stealth requirements the Navy expects from it. Thank you for watching Dark Skies. Please make sure to hit the like button and subscribe to all our Dark Documentaries channels for many more technological and military developments. And don't forget to activate the notifications bell to be the first to hear about our new videos. Stay tuned.